We start now. It's really great having participants from different time zones in this webinar. Thank you again very much. So I'm giving a basic introduction about why we decided to have this webinar. We see that there is a lot of increasing digitization and collection of data gaining vogue in the maritime industry. So the next question which arises is obviously whether such data can be put to use to increase the efficiency of performance of a ship or a fleet of ships. Now, performance of a ship has several aspects. There can be safety and the regulatory aspects. There can be fuel savings, performance improvement in terms of fuel savings. There can be performance improvement in terms of optimization of the operations. Hence, there are several perspectives involved in the vessel performance as such. So we have to understand the various perspectives. With this reason, we combined this webinar with 3 speakers who will give a different aspect or different perspective of each aspect. So we have Mr. Apurba Ranjan from IRClass. We have Mr. Erik Bjorkli from Kongsberg Digital, and we have Mr. Prashant Singh from Man Energy Solutions. So these 3 speakers will be providing their different perspectives through their presentations later. Now there is some further information regarding this webinar. After the 3 presentations, we will be having a user poll where we'll be sharing some standard questions with the users to know their view, and possibly several of the questions that you may have during the presentations may be answered when you see the results of this poll, and the results will be shown to you live during this webinar itself. We do not have a verbal question and answer session, but we have a question and answer text box which you all can see on your top right corner. So you can please type your question in, and we will try to answer as much as possible the questions. And if some questions are remaining unanswered, then we will definitely endeavor to answer them and provide you after the webinar. At the end of the webinar, after maybe a week or so, we will circulate this video which is being recorded, and also the unanswered questions along with a feedback form. So I now move to the first speaker for the webinar. He's Mr. Apurba Ranjan. He's from IRS. Mr. Carr is a naval architect by education. He has been working in IRS since more than previous 27 years. He has worked in various capacities and roles. I mean, in plan approval division, in ships in service division, and in research division. His specializations include risk analysis, hydrodynamics, and FSA. He has also worked in various international projects in IX, EU, Asian class societies. And he was the ex-chairman of the IX expert group on formal safety assessment, and he is the current chairman of the ACS working group on safety. Prior to IRS, he has worked in a shipyard for 10 years. So Mr. Carr, I'll put you live. Please share your presentation.
Thank you, Karan, for your generous presentation. Introduction. Yes. I hope my slides are visible now.
Yes, they are. Mr. Carr, you can go ahead with the presentation.
Thank you, Karan. Thank you, Karan. Thanks for the introduction. Yeah, in this presentation, I'll be providing a brief summary on relevance and importance of data from the perspective of a maritime regulator. Just to provide a brief introduction on about Indian Register of Shipping, which is shortly known as IRClass, which I belong to. Sorry, something is.
Mr. Carr, please make it full screen so our audience.
Yeah. Okay, full screen now. Okay,
yes, that's fine.
Fine. Yeah, IRClass is a classification society established in the year 1975. By now, about more than 1,200 ships classed with total gross tonnage over 11 million GT. It is authorized by 46 flag administrations to undertake statutory certifications. It is headquartered in Mumbai, India, with global presence across Far East, Middle East, Europe, and America. It has been a member of IX, that is International Association of Classification Societies, since the year 2010. Now, as regards data, how the definition of data from the perspective of a regulator. It's the information recorded on board ship which is derived from the operations of the ship and surveys and inspections. For ship components, for example, hull, machinery, control and automation systems, so on and so forth, and also the cargo and crew. This data may be recorded manually or automatically in continuous or intermittent manner. Various types of data recorded by ship systems. Just a list of some typical systems is given here, which is though not exhaustive. Is for example hull structure, propulsion systems, control and automation systems, safety systems, navigation systems, communication systems, cargo monitoring, loading, discharging, and the IT systems. Now, the advances in electronics and communications enable recording, transmitting, storage, and analysis of data in real time. Amounts of data recorded and stored depend upon the data collection systems. Data is an important indicator of the condition of the ship as well as the operations. The cost associated with this data acquisition analysis is an important factor to keep in our mind. That is, to what extent should we go to collect data? This has to commensurate with the benefits we get out of this acquisition and analysis of data. Now, as regards the relevance of data for a regulator, the traditional role of a maritime regulator was to scrutinize the ship's plans, drawings, reports, and reports of periodical surveys and inspections to ascertain compliance with applicable rules, regulations, and procedures. The advances in data collection and analysis has presented newer opportunities to regulators to extend their oversight of ships' condition and performance. This, of course, comes with some associated challenges. Firstly, how to determine the goals and objective of data collection. Then to determine the scope of data, which data, what data. Then to ascertain the sufficiency of data for use in regulatory process. Then to ascertain the accuracy and integrity of data. Then to assess the interpretation of data to draw meaningful inferences. Then ascertain the reliability and robustness of data collection, storage and transmission systems on board, and ensure protection against malicious attacks, which has become now very important, cybersecurity. Now, a regulator entrusted with data from a fleet of ships has also to ensure robustness of his own systems to make sure the protection, use, and privacy of this data. Now, how data provides opportunities to regulators. Data can help to monitor and ascertain the condition of the ship in real time rather than only during periodical surveys, which in turn helps in predictive maintenance, condition-based monitoring, risk-based inspections, emergency response. Again, also to improve rules and regulations, it can support performance-based design, structural loads computations using the typical trade routes obtained by using AIS data, weather data measurements, and also ascertain corrosion margins in rules, so on and so forth. Then root cause analysis of accidents and damages. Then scope and intervals of surveys inspection determined using assessment of data instead of a fixed scope and fixed intervals, which is currently in vogue normally. And also it can reduce the need for physical inspections. That is, we can go for more and more remote surveys, so that's less dependent on the physical presence and the physical inspections. It can also help in effective monitoring and implementation of regulations as to whether the intended targets are being achieved and to set future benchmarks for newer regulation developments or amendments of regulations. Some more opportunities may be the emergence of complex systems, which is a buzzword now in our industry. Onboard ships demands emphasis on data acquisition and analysis. Given the complexity of data collection, storage, and processing, suitable human experts is also required. So now this requires transition from the traditional roles of naval architects, marine engineers to more electronics, computer science, data science, and artificial intelligence specialists. Hence, the regulators need to gear up to meet the expectations and support the maritime industry accordingly. Class societies may also support the industry in analysis of data and providing advisories in the aspects which are outside the regular class purview, especially those stakeholders who may not find maintaining a separate team internally practically or financially viable. Now, some note of caution. Obviously, data helps in reducing the uncertainty and assumptions for ship design and operation. However, too much of data also increases the complexities and costs. Fortunately, newer techniques and algorithms are emerging to work with large amounts of data and draw meaningful conclusions and inferences. So a right balance is required between the reduction of uncertainty and the complexities involved. So a right balance has to be achieved. We are entering in the new era of data sciences. At this stage, it deserves careful attention in drawing out the right strategy and framework for a really fruitful and effective outcome. So as it says, well begun is half done. Thank you very much. Thank you very much. Yeah, so now I hand it over back to Mr. Karan. Yeah.
Karan, you're on mute.
Sorry, I was muted. So thank you, Mr. Kar, again for that nice presentation, which gives several aspects of the data from the maritime regulators perspective. Our next speaker is Mr. Erik Bjorkli from Kongsberg Digital. He has majored in electronics and graduated from the Royal Norwegian Naval Academy. He has worked in various roles during his career at Kongsberg Maritime, which spans nearly 20 years, and which gives a very good perspective of the various disciplines involved to him. He has been the head of the Cognify partner program relevant to the data collection systems. Prior to joining Kongsberg, he has served as a submarine weapons and sonar officer on Norwegian naval submarines. So Mr. Erik Bjorkli, you are requested to share your presentation and your live. Can you please share your presentation?
Yeah, thank you very much. I find it really nice to be invited to this webinar. So thank you very much for that. It's a great opportunity, and I think it shows what digitalization is all about. It's about collaboration, it's about sharing experience, and this is done in new ways, utilizing these tools. So we see that stakeholders that previously were competing or not talking at all now get together to really move the industry moving forward. So it's been a fun journey for me as well, working in this industry for more or less my professional career. So I'll take you through a few let's say reflections from my side on and show you how we work with data from Kongsberg. Kongsberg being many of you know Kongsberg from before, of course, but we are from the operational side. We supply the equipment on board. We do ship designs, and with the acquisition of Rolls-Royce Marines, we have even more hardware in our portfolio. But all of this produces data, and this is what I'm going to talk about today: how we work with data and a few use cases. Unfortunately, we don't have time to go through many of them. There's a lot of exciting stuff to talk about in this context. But just a few seconds about Kongsberg. It consists of 3 business units. It's the biggest one is Kongsberg Maritime, with the acquisition of Rolls-Royce Marine recently. They're by far the biggest ones. And then we have a defense business industry that works with developing defense equipments for our allies. And last, it's the little brother, Kongsberg Digital, which is growing fast, trying to disrupt our own business from the inside in many ways. Working very close with Kongsberg Maritime primarily, but also to some extent the defense industry. And the common thing here is that we use technologies in between the companies in kind of in high-tech areas. So what is really driving the industry moving forward now? And I think in many cases we're on the verge of a digital disruption and transformation in maritime. And a lot of some of the main factors, as we see it, is that the new regulations coming in is really driving this. There's this huge and massive pressure on environmental regulations, with emission reporting and sustainability being in the core focus of the entire world, really, and shipping included. Enabled by new technology. Oh, would you believe that? I have a fire alarm. Okay, I'll just continue and apologize for this. Wow. Okay, so technology being a driving factor, we have cloud computing and IoT enablement that is now helping us to drive this change. The market is expecting lower costs and utilizing this technology to move forward. And of course, you have the people that is on board and on land that expects new services and ways of working compared to what they used on their tablets or in their daily work, and not to walk around typing down different types of data in spreadsheets like they used before. Oh God, that ended. Thank you very much. Yes. So inside of Kongsberg, we also struggle with the digitalization, how to move forward. We had probably 4 or 5 different ways of transporting data through our products and our legacy. And with the acquisition of different companies, we also get more technology in. And we see that we struggle with a lot of the same problems like the rest of the industry is struggling with. And what you see now on the screen is a mapping that we did ahead of an initiative we call Vessel Insight. And it's the fact that there is not a problem of choices when it comes to choosing solutions for digitalization. It's a lot of them out there, and in Kongsberg we had a lot too. The question is how you make it scale. How do you make this thing move forward and get volume on it? Because in software there is one thing that really is a driving factor to make a success, and that is volume. And in the shipping generally, we lack standardization, and we lack a common ground to develop our applications. So in Kongsberg, we decided we need one infrastructure. So we're going to take all of these technologies that we have, take the best out of them, and develop one for all of us. So it's really an internal cost efficiency project. But then we also saw that we need to get the rest of the world to join us into this as well. So we wanted to make it non-exclusive. We asked anyone around us to join, and the reason why is because we think that these solutions, they don't scale because there's an inadequate ROI for each solution to create their own infrastructure. We see it with some of our partners and customers who have been trying to create their own solutions, collecting data from, some of our customers have 800 ships. They do in-house development, but it doesn't scale. And the same thing is our experience. We have several hundred installations, but without a bigger scale, the lifecycle management cost is getting too high. And then you have the issue of data quality. You need standards, and to be able to make standards, you need to collaborate with the rest of the world around you. And of course, cybersecurity being a main factor of concern for our customers. And the more pipelines, the more connections and interfaces you have to your ship, the higher the risk. So that's why we decided that we wanted to create an infrastructure. We went to the market with this in North Shipping about 2 years ago. Vessel Insight is really taking the legacy of Kongsberg with 3 decades of being an integrated on ships. The maritime industry was really quick adopting automation on ships, and this is what Kongsberg has been doing for 30 years, is to connect those switchboards, the engines, the propulsion, the thrusters into the automation system on board. And then, of course, many of our customers have been sharing that data through the history stations on email exchange, but that's not really the way moving forward to standardize on data. It's really the new technology enables better interfaces and sharing. So Vessel Insight is an infrastructure enabling the customer to share their data from all of these sub-assets through a cloud API interface, to say it really quick and sweet. And it's not just for Kongsberg. We have opened this up, and I'll be very honest with you all. It's been a journey for Kongsberg to open up sharing, our data, but it's not really our data. It's the customer's data. And what we do is enable them to share that with whoever they want to share it with. Getting access to data alone is not necessarily the end goal. And as Mr. Carr said, you have to have a contextualized setup with it. You have to know what you are getting there, because in many cases customers come to us and ask, we want all the data, and we give them all the data, but it doesn't make sense to them. You have to make sure that you know what it's all about, how it's scaled, is it filtered, what asset is it connected to, and contextualize it. And that's the kind of engine that we're putting on top here, so that it makes it a low threshold to share that data with our applications. These third-party platforms are typically the MAN Xeon cloud. We have already a partnership with DNV Veracity. We have partnerships McGregor, and everybody has their own platform. If you're a serious player out there in the market today, you have some sort of place that you put your data securely, and so we allow for that as well. Ultimately, the goal here is to create a marketplace where we can enable our partners, our customers, to test and trial applications at the lowest possible threshold. And what we're doing with MAN that Prashant is going to tell you more about later is how to optimize that interface. How can we reduce the load of data? And this is what we're doing with DNV and others. So one example there, as Prashant is going to tell you more about the MAN interface later. I won't steal his steal. But the ultimate goal here is to have a full toolkit of applications and services for the customers to choose from. Test, trial, maybe drop it, try the next one at the lowest threshold possible. One example that we've done that I was proud to be a part of myself pretty early was with Bourbon Offshore and Bureau Veritas, is the annual DP survey for supply ships. I'm a DP engineer myself, so I know how much efforts goes into this process. And digitalization is really just replacing a manual process with more efficient tool. It's like a lean process. You take that manual process because we already have the data instead of inspecting the gyros, you can observe them over the full year, see if they deviate and how they behave. Instead of observing the reference systems, the GPS, is it okay? You can observe it over a full period of a year and then determine whether or not that is good. So you take that manual process and replace it with digital efforts. As long as you have the data, it's amazing what you can do. Eventually, we managed to get the whole annual DP survey replaced with a digital process combined with tests that the crew do themselves, just to log what's going on. And by operating their assets in a specific way, making the movements that you typically would do on a survey, they could do that while they're idling for an operation on a job or something like that. In some cases, the survey and the class requirements are to observe the crew, do interviews, but that can also be done remotely. It's amazing what we do remotely these days, where we connect different stakeholders, not just to our equipment, but also connect third parties and so on. Vessel Insights, the kind of hub in Vessel Insight is the API. And that's where we build our alliances and relations in. Our customers get the ability to connect the chip through an API and share their data. And in addition to this, you also get the ability to do some visualizations. What you see here is an engine modeling. Some of our use cases with our customers are, do I overproduce lube oil? Well, how do you know that? You have to have the data. And then we can model some setups and visualize whether or not you are or not. All right, then we'll leave it at that, I think. I'm sorry for the fire alarm. It got me a little bit set off there, but I hope it was interesting. So I'll leave the word over back to Karan. I think he is still muted, Karan.
Thank you, Erik. It was a really nice presentation, and it really gives us a lot of perspective on what all data collection systems are there and how you really use data for various purposes. Our next speaker is Mr. Prashant Singh from MAN Energy Solutions. Prashant is a mechanical engineer by background. He did his post-graduation in marine engineering and naval architecture. He later did his MBA from the Copenhagen Business School. He has served as chief engineer on board gas carriers, specifically ammonia carriers. He has also worked at Maersk Line prior to joining MAN Energy. So Prashant, you are live. And can you please share your presentation and proceed?
Thank you, Karan. Thanks for that kind introduction. So as Bent actually earlier said, it's a good opportunity for different stakeholders to come on stage and present how they are using data and in future how is it going to impact the maritime industry. I come from the retrofits and upgrade department for MAN PrimeServ Copenhagen, and I would be presenting the MAN's perspective of how we are using the data. So just a brief about MAN Energy Solutions. It's a 250-year-old company. Constant innovation has been mantra of MAN Energy Solution over the period of the years, and we are putting all three: time, effort, and money towards making shipping more sustainable and greener in future. An example of this greener future for maritime industry is our dual fuel engines, which not only runs on LNG and LPG fuel, but now we have started researching for ammonia fuel as well. Our ammonia engine should be soon rolling out, probably a couple of years down the line, and this will be a major milestone when it comes to decarbonization of shipping. Moving forward, there are two core strategies on which MAN progress has rested. As I mentioned, the decarbonization, we want to make maritime industry carbon neutral by 2050. But now let me focus on the topic of digitalization. Now, data-driven digital solution sits at the core of man transformation. We are using data analytics towards helping improve the vessel performance since last decade or so, and now all the new future solutions which are being launched are heavily rested on the data feedbacks and data analysis. In the next few slides, I will talk about a particular solution, using which we are using data towards improving the vessel performance, and we call that system as PrimeServ Assist. That solution as PrimeServ Assist. If you will look at this picture on the slide, what we are doing effectively here is we are actually bridging the ship to shore gap, the data gap which we have. We are connecting the ships to shore, and when I say shore, it does not only mean our man PrimeServ center or remote operation centers, but it can be your head offices. At any point of the world, you can see how your two-stroke engines or your four-stroke engines are behaving and operating right on your table, on your laptops. The idea and why are we trying to do that? I would say there are three main points: is to provide proactive maintenance. The second being instant technical and performance support. This is which would be provided by our MAN experts to the vessel superintendents or to the vessel staff. And the third is data visualization. When I say data visualization, that means data visualization on shore. In the next couple of slides, I will dive in a little deeper to understand how this is running, how this we are already, this solution is already operating on many vessels around the world, and how we are helping improve the vessel performance. So as mentioned, how we are leveraging data to improve vessel performance. There are three main points. The first is proactive maintenance. What do we mean right now? What do we mean by proactive maintenance? That is, right now, a lot of maintenance on board is quite reactive. That is when the breakdown happens or when the problem appears, then the maintenance is done. So that actually leads to a lot of downtime. We are trying to address that before the problem will happen or may happen. We are trying to, by using the data, by analyzing the data in the correct way, we are trying to predict the breakdown and thus reduce the downtime. The second is the performance support to the ships, optimization of cylinder conditions. With the data analysis, which we are doing constantly, we can predict how's your liner wear conditions, how's your piston wear conditions. Can you reduce the lube oil consumption or not? Or is there a scope of reduction of fuel consumption or not? So we are directly trying to impact the operational cost of the ship owners and the maritime industry by the performance support to vessels using data analysis. The third and the last point, I would say, is data visualization. Now this brings me to the point when I used to sail on the vessels. There used to be a month-end work we used to do, that is the performance monitoring of vessels. We used to do it once a month, or maybe at the max twice a month. By using data visualization on shore, you can actually carry out performance report without any manual animal, without vessel staff getting a lot involved in that. At any point of a given time, any number of times you can actually carry out. So thereby our goal here is to keep the engine operating at the maximum efficiency at all times. This is what we are trying to achieve by data visualization on shore. I would request you to see the information circle here, the blue circle. How is the ship actually getting assisted by our remote operation centers, or how is the data flow happening? The first thing is, through the PrimeServ Assist platform or the data platform, we are extracting the parameters of the main engine, of the two-stroke engine, the four-stroke engine, and it is that data is sent to our cloud platform, which is known as MAN-Sion cloud platform. And from the cloud platform, it is directed to the different remote operation centers we have in Copenhagen, Germany, Houston, and over there, artificial intelligent algorithm will check the data which has been received from the vessels and detect any anomalies, or any errors, any deviations. And once that errors have been detected, it would be rechecked by our experts who sit in those remote operation center 24/7, and then those deviation or corrective measures would be sent to the vessel or to the vessel superintendent, either by means of email or by means of the platform, direct text message, thus making the whole system proactive and not reactive. So before a problem might happen on the vessel, we are trying to inform the vessel staff, okay, you may want to go and check this particular parameters, or you may want to carry out some maintenance. So focused maintenance can be achieved. So this is the information flow of the data by means of which we achieve the proactive maintenance. Now, just digging in a little deeper, by using this proactive maintenance, what are we trying to achieve in for example, in any engine? Let's say we receive a lot of data based on the engine balance. We receive the cylinder pressures, the peak pressures of the engine, and by using that, by analyzing that data correctly, we can help the shipping companies reduce the NOx emissions. We can help the ship reduce the fuel consumption on the vessel. The second thing is heavy running. No one wants to run a overloaded engine. Overloaded engine leads to breakdowns and higher operational cost, maintenance costs. So we are collecting all the data from your engine with respect to heavy running, and we will inform, or our AI platform will inform the vessel that your engine is running presently in overloaded condition and you might want to reduce that. The third thing, and I would say my favorite thing, where we are using this data platform, is engine control system and user settings. Computers are creeping in everywhere. This is a world of automation. Ship staff are not only responsible for doing maintenance on two-stroke engine, but there are so many other equipments on board the vessel. You cannot train every single person on hardware and software and everything, and that's where this could be quite helpful for the ship staff. We will take care of your engine control system, or the data which is being given by the engine control system. We know how to actually use it towards towards solving problems with the engine control system and making sure the ship stays in safe maneuvering conditions all the time. The last, and I would say one of the important thing, is the cylinder condition. So data from cylinder condition is being collected all the time. Your piston ring wear, your cylinder liner wear, which contributes quite a lot to the maintenance cost, can be reduced by using, by analyzing the data, the progressive data which we receive from the vessels. So these are four main impact areas for an engine, by means of which we can make the engine operation quite efficient. Now, this was a little bit about how a PrimeServ Assist platform or data connectivity platform is helping ship owners. Now, let me show you in the next slide that how are we designing new engines based on the data, based on the data usage. So Man Energy Solution is utilizing data towards building new engines and retrofitting existing fleet. So what are we doing right now is we are improving the fuel optimization for ships by using the data monitoring. Data from cylinder monitoring system is constantly used, analyzed, and automatically retune the engine or readjust the engine towards working at the most efficient stage. Similarly, for cylinder condition improvement, we are collecting the data, and before a scuffing of the liner or before the scuffing incidents or breakdown of the piston rings happen, there would be a warning sign which would be given in the engine control room that you may want to check the vessel performance here. The last, and I would say, as Mr. Kerr pointed out earlier, cybersecurity is very important and a lot of companies are facing the data breach problems, and cyber attacks are happening. That's where data exchange between ship to shore is constantly monitored, and we are making sure that there is no data, no third party can access the data, or there are no internal and external virus ingress in the propulsion plant. So this is how, looking at this, we are designing the new engines. All of these would be standard features, but not only that, we are trying to impact the existing fleet as well by retrofitting new solutions. This is data, how we are using data. The last, I would say, point is how we are working with different stakeholders here. For example, Kongsberg, and IRClass, and how will it actually affect the data future? We see the remote survey of vessels and classification society requirements becoming easier. Now we know for a fact that when class gives, when there is a COC which is given, condition of class which is given, the sailing requirement becomes quite stringent. And let's say for a 2-stroke engine, or for a 4-stroke engine. So by using the data analysis on shore, we see that there could be an easing of compliance standards in future, so that it's a win-win situation, not only for us, but more importantly for our customers. Some of the other benefits I've listed out here is greenhouse gas emissions. Shipping industry has a big percentage of greenhouse gas emissions presently. By analyzing the data, by building new solutions in future, we see lowering of GHG, and of course moving from preventive maintenance system to condition maintenance system. And I would say one last step, and that is taking the steps towards truly autonomous shipping. Showing that collaboration, we have recently collaborated with Cognify, as Bent actually previously mentioned. By using Cognify system, we are not only collecting data from our 2-strokes and 4-stroke engines, but also from the alarm monitoring system. And how will it help the customers here is that we can do better analysis of data. We can be more proactive towards the maintenance. We can prevent more breakdowns happening on the vessels and improve the efficiency of the vessels. So that's it from my side. I will hand over the command back to Karan. Thank you, Karan. I will hand over back to Karan.
Thank you, Prashant, for that very nice and very elaborate presentation. This really gives a lot of insight into how the future could turn out to be with the use of data, and even now when the data is being presently used for so many purposes. As I mentioned earlier at the start of this webinar, we are now having a user poll where we will like to seek feedback from the various participants as to what they think would be the future of data. So I am just posting a link along with the for the forms which the user can fill up. It will be very nice if this could be filled up, and we will show the results immediately. We will show the results within 3 minutes. So every participant has 3 minutes to fill up this form quickly. So please do so. The time starts now. We exactly have 3 minutes to fill up the form. And the Q&A session will follow after this. So the results are there on the screen for everybody to see. So out of the participants of the poll, which we had 45, we can see there were more ship owners and there were a lot of people in the other category. The academia and universities also were quite a large quantity. So as to the question as to whether you have data collection deployed on the ships, so 13 responses say yes, and 24 of course cannot say because they do not represent the ship owners. There is very good unanimity that the use of collected onboard data will contribute to the improvement of the vessel performance. So we can see a good unanimity between all the participants as to what are perceived to be the challenging factors for the deployment of onboard data collection. We can see that cost, operation, installation is the major part, and the second part is a difficulty in installation on the existing ships. And of course, there are participants who feel that more encouragement is needed from the regulatory perspective. Erik, I'll come to you since you have been installing such systems. On the first two points, the cost of installation and the difficulty in installation, could you enlighten the audience as to whether these are really very difficult factors or they are not as difficult as they seem to be? Erik.
Yeah, that is, of course, an important factor for our customers and a threshold to start digitizing. So this is a constant project of ours to reduce the cost to bring this out in volume. What we've achieved now with the latest setup is that we are, with our newest automation systems, capable of sending that equipment on board for the crew to install themselves, and the cost of the equipment is included in the subscription. So we're selling it as a service in the new service as SaaS business model. And in case we have to send someone on board because it's a legacy system or has some complexity connected to it, it drives the cost. But it's continuously being focused on to reduce the cost and lower the threshold to start this journey for our customers. So on the infrastructure side, we're doing a lot, but there are complexity in this setups with a variety of types of ships and types of equipment. And in many cases, the problem is not necessarily receiving the data, but finding how you can send the data from legacy old equipment. So this is also something that we collaborate with MAN. How can we make the full fleet of legacy engines and legacy equipment, legacy automation systems connect to our infrastructure in the cheapest possible way?
Thank you, Erik. So I'll come back to the questionnaire again. And the next question was which type of data would be necessary to be collected and stored. So almost all participants feel that the propulsion system data is a very important data, which would involve the main engine, auxiliary engine parameters. Navigation systems, automation control systems, and the environment systems are also forming another part. Would any of you like to comment on this? Erik or Prashant, do you have any observation on this?
I think it reflects very well what we're seeing as well. Fuel is obviously the main OPEX factor for a customer, so that's obviously very interesting, and that's also why we chose to start a collaboration with MAN. Another really interesting factor here is that your assets, the ships, are also interesting for a lot of other stakeholders. So those sensors that's sailing around the world, and I'm thinking more specifically on the environmental sensors, could be actually something our customers could sell because it's their data, and connecting that in a bigger perspective is something that we see someone is starting to look into. It's a really interesting perspective on utilizing your data in a new way. I don't know, Prashant, if you have any other views.
Yep, I agree with you, Bent, actually. So propulsion system being one of the biggest plant on board the vessel, contributing towards the maximum operational cost. And if we get the data, we analyze the data from the propulsion system, it definitely directly impacts the vessel operational costs. So it makes all the sense, and I'm not surprised when the participants have chosen that to be the top priority.
Thank you, Prashant. If we move towards the next poll question, which areas would be significantly influenced by the collection of use of onboard data? So as expected, a large majority of participants deem that there will be fuel savings. Another category is the optimization of vessel performance and the scheduling and maintenance. So yes, 17 participants think that cybersecurity also is an important aspect, as this is slowly turning out to be. People are realizing that yes, cybersecurity is a very important aspect. Would any one of you like to comment on this, Prashant? The cybersecurity, Prashant, yep, or Erik? Prashant first.
Sure. As you know, in last few months, we have seen this twitters of some very big shipping companies, where their actually data were breached, they were hacked. So shipping industry is not isolated when it comes to data hacking, and data breach. And that is why IMO actually came out with this regulation that is by 2021, cybersecurity should or must be addressed by ship owners as a part of a safety management system manual. And that's why I'm not again surprised when people are or shipping industry is awakening to the fact of addressing cybersecurity. And some of the solution both with Kongsberg and what man has got actually has cybersecurity from which addresses right at the core. So we are taking it seriously, and in future we hope to reduce this incidents happening to shipping companies soon.
Thank you, Prashant. The next poll question was that would you deem that special expertise would be necessary for understanding and processing the collected data for fine-tuning vessel performance? So it's a very overwhelming majority of 43 out of 45 participants that they think that yes, such an expertise would be necessary. Mr. Kar, would you like to come in on that to give up your perspective on this, since you mentioned that in the slide?
Yes, Karan. Yeah, thank you. Yes, of course, with the current traditional approach, I don't think we can address this issue effectively. We need to expand our skill set, our knowledge base. We need to induct new types of experts, which are even till now, we are a marine industry, we are not very familiar with experts like artificial intelligence and machine learning. So I think, and I'm quite sure that we have to expand our domain knowledge. Yeah. Thank you.
Thank you, Mr. Kar. We'll quickly move through the next two questions, which are the last questions. So the security of data. So yes, 35 participants do have concerns whether there will be security of data, whether stored on their systems or third-party systems. I think Prashant discussed very well regarding the cybersecurity aspect. And the last was whether it would be preferred to share data with class RO flag. So a majority feels that yes, this is really possible and they would like to do it. So with this, I conclude the poll results, and we'll come back to the Q&A. It can be seen that Professor O.P. Shah has some questions on the digital twins and the. Just a minute.
Yeah, Karan, before you go to the question, can I have some comment on the last item? Would you prefer sharing data class RO flag to enhance regulatory compliance?
Yeah, sure, we can. Yeah.
Yes, because this actually, when industry enters class societies or RO to provide their data, to share their data, it puts a lot of responsibility onto us to make sure that data is well protected and data breach doesn't take place and data is not leaked out. So that we have to deal with now. We regulators is a big challenge and big responsibility onto us. Thank you. Yeah, that's it.
Thank you, Mr. Kar.
Just a comment there, if I may.
Yeah, sure, Erik, sure. Please come in.
The ultimate goal here is to enable the customer to share parts of the data that they would like to share that obviously will receive some sort of benefit. So I think it all depends on what kind of benefit the class society can provide the end customer. So and in any case, it's a matter of a limited set, and the threshold and the competence may not be that you have to have a lot of competence on it. We're trying to lower that threshold all the time. A few sets of data can reduce some pain points for the customer. So my recommendation is to start with something small and then build on it, just because digitalization isn't really a quick fix. It's a journey.
Thank you, Erik. So we are literally running out of time, so I'll come to the Q&A and maybe we can take one or two questions. So the first question is from Professor O.P. Shah from IIT Kharagpur, and he has the question whether how does class envisage the future of data? I suppose that is his question. Would you like to come in again, Mr. Carr, on that?
Yes, Karan, I have already replied to that question.
Okay,
I have
okay.
already replied.
Okay. We have some more questions, especially.
Yes, can I verbally also elaborate that a bit?
I suppose we can have some other questions where people have asked about the practical application. There is one question where from Mr. Prabhu, where he is asking, may I know the predictive maintenance applications you have implemented with respect to cylinder liners and valves? So Prashant, probably can you reply to that?
Yeah, sure. So with cylinder liners, we have something known as liner wall monitoring. What liner wall monitoring does is actually it checks the rate of increase of the jacket water temperature, and if if there is a normal increase of engine load, we know how the jacket water temperature increases or the liner wall temperature increases. But however, if there is a scuffing which is going to happen, then the rate of increase of the temperature would be different. And now that is what is going to be sensed by the algorithms we have introduced in the engine control system, and which will give a warning to the chief engineer that or to the vessel superintendent that there is something wrong on this particular unit, and you may want to have a look at that. So that is one of the practical applications I just spoke about.
Thank you, Prashant. We have another question from Mr. Gaurav Mehra. He is asking, how do you see an integrated approach to data acquisition and analysis, considering the various suppliers involved in a propulsion or power management system? I think Erik, would you like to come in there, or would you like Prashant to reply?
Let me see if I can find a question here. So the question was then how it is.
How do you see an integrated approach to data acquisition and analysis, considering the various suppliers involved in a propulsion or power management system?
Exactly. Yeah, a very good question. So our approach is to collaborate. Really, the first customers that we now work with is obviously not solely Kongsberg customers. We have a variety of suppliers. So for those first customers, we work with them and then collectively go together and see what kind of pain points they have. And if they are relying on getting data from other vendors, we typically go in and request if they're capable of sharing it and what it takes to do so. And in many cases, including Kongsberg, historically have been pricing this extremely high. But to lower that threshold, because we supply the infrastructure and also enable that specific vendor to get access to his own data under the principle that, yes, I will share it, but I will also compete with equal terms so I can get access to that data and also supply my additional services. And I think that resonates very well, both in the market and with the application suppliers. And I think that's also the principle that we will see moving forward, like for instance, MAN and others.
Thank you, Erik. There is one more question by an anonymous participant. He's asking, engines will be rolled out early without much testing because data collection is going to happen on platforms. Reduction in engine performance research costs, reduction in the cost of the engines, increase in cost of the spares with, increase in cost. Yeah, reduction in the cost of the engines, increase in cost of the spares with engine manufacturers quoting various collected data parameters as requirement for preventive maintenance, and therefore increase in the predictive maintenance costs. So yes, new engines will be rolled out with better performance based on collected data, but the preventive maintenance cost, this will take time and the cost involved with the whole thing will be large and will be borne by the ship owners. Prashant, would you like to reply to this? It's a large question with several aspects.
Yeah, so I think, commenting on the, I would say, nutshell of the question here, and I think it's a good question. It's a good concern, which the participant is trying to address here, that the probably the cost of the predictive maintenance is going to be high. To begin with, any cost would be higher. Predictive maintenance cost is higher, but over the period of the time, when you look at the return on investment, the consequence of implementing those automation solutions, and it will even out probably in a period of 1 or 2 years.
Okay, thank you, Prashant. And there is we can take one last question where it is by Mr. Baranidharan. Plant maintenance are costly when compared to predictive maintenance. how to reduce spare cost by improving on preventive maintenance using data with help of AI. So I think Prashant, maybe you would like to comment on that.
Yeah, so we are already doing that. Actually, we have a lot of vessels all over the world which are running with this data management system, and we are already looking at increasing the time between overall of the piston rings of the cylinder liner. That means before the actual surface deterioration of the cylinder liners or the piston ring happens. I'm just giving an example here. We can actually predict that. So before the actual wear is going to take place, the speed rate can be increased, or things can be altered by using with the TBO can be increased, and those savings can be achieved.
Thank you, Prashant.
That's how we are using the data. Yeah.
So thank you, Prashant, for that clarification. As you see, we have already overshot our time duration of 1 hour for this webinar, and so we will have to unfortunately end the Q&A here. We'll definitely reply to the unanswered questions and send you the copy of our answers. We'll also share the recording of this webinar and make it available to all the participants. This will also be available on our IRClass YouTube channel. So please do visit the channel and subscribe to it for the regular periodic updates. So with this, I thank Mr. Apurba Ranjan Kar, Mr. Erik Bjorkli, and Mr. Prashant Singh for taking out time. I also thank the participants for turning out in large numbers and really showing a lot of interest in this webinars, especially their input to our user poll as well. We hope to do more such webinars in the future. But at this moment, we must call it a day. So thank you again, and goodbye all of you. We will send you the links and the Q&A answers by mail within maybe a week or so. Thank you again very much. Thank you. Good day.
Thank you.